Hey, what's going on, guys? In this video we are going to see how to design a circuit based on an equation. Here we want V output voltage is equal to 3V2 minus 5V1. To derive this equation we are going to use difference amplifier and we are going to create a circuit, and the circuit is going to give us V output voltage that is equal to 3V2 minus 5V1. Okay, and when we use difference amplifier, the voltage output equation is going to be this one, RF over R1 times V2 minus V1. So this is the equation for voltage output when we use difference amplifier. But this is only true if the R1 over RF ratio is equal to R3 over R4 ratio. Otherwise we will have this equation, V output is equal to RF over R1 times 1 plus RF over R1 over 1 plus R3 over R4 V2 minus RF over R1 V1. Okay, in our case we have 3V2 minus 5V1. We don't have the equal coefficients, right? If we have equal, we can use the first equation. Since we have this one 3, this one 5, we have to use the second equation. Okay, now let's go ahead and see. So here we have let's start with the second one. Here we want 5V1, so we want the RF over R1 ratio to be 5. So let's say RF over R1 is equal to 5, and if we put that equation, this is 5, and then the equation is going to become VO is equal to, here also we have RF over R1, so this is going to be 5 times 1 plus RF over R1 again, that's going to be again 5 divided by 1 plus R3 over R4 times V2 minus RF over R1, that's equal to 5 V1. So we found out this ratio 5, and we want the second, this R3 over R4, and actually this whole thing equal to 3, because this one multiplied by V2, we want the V2, the coefficient of V2 to be 3. So to derive that one, what we can do is we can equate this equation like 5 times 1 plus 5 divided by 1 plus R3 over R4 times, we can forget about V2 for now, we just want this one to be equal to 3, right? So let's see what we can do. So here we have 5 times 6 divided by 1 plus R3 by, this one is R4, so R3 by R4, that should be equal to 3. Then therefore let's multiply this 5, so this is going to be 30 over 1 plus R3 over R4, that one must be equal to 3. Then if we bring this one to this side, this is going to become, okay, let's write with a different color, and also I want to small this one. Okay, here we have 10, because if I bring this 3 to this side, this is going to be 30 over 3, that's going to be 10. 10 is going to be equivalent to 1 plus R3 over R4. Therefore R3 over R4 ratio is going to be equal to 10 minus 1, that's equal to 9. So we are going to have this R3 over R4 ratio is going to be 9. In that way you can see, if we plug 9 right here, let's choose a different color. So VO is going to be equal to 5 times 1 plus 5, that's 6, and 1 plus 9, that's going to be equal to 10, and then times V2 minus 5V1, and then 5 times 6, that's going to be 30. 30 divided by 10, that's 3 V2 minus 5V1. VO is equal to 3V2 minus 5V1. Okay, so these are the two ratios that's working. RF over R1 is equal to 5 and R3 over R4 is equal to 9. Okay, so based on this equation, now our purpose is to design the circuit. So we have derived this ratio. Now all we have to do is we have to put the values for this resistance in such way that will give us this ratio. Okay, you can pick any values. Here I can choose 50 kilo ohm for RF. So we want the RF over R1 ratio to be 5. If it's 50 kilo ohm, then this one must be 10 kilo ohm. And also we want R3 over R4 ratio to be 9. So we have to pick some values in such a way that gives us 9. So we can say R3 is equal to 90 kilo ohm and this one is equal to 10 kilo ohm. So R3 over R4 will give us 9. And that's how we derive, like we create the circuit based on an equation. I hope this helps. Thanks for watching.